Now, cylindrical fold. This is a term I used a few minutes ago. This is when your hinge line is nice and straight. So there's only one fold going on here. If you think about taking a towel and draping it over a long rod, like in your bathroom, your towel rod, and then you take another towel and you drape it over that one, and another towel and drape it over that one, you would get something kind of like this. You'd have 3 towels, so you'd have 3 layers, and they would all have a straight hinge line, a straight fold along that bar, along that cylinder that they were draped over. So that's a cylindrical fold. On the other hand, if your towel rod is really weak, or your towels are incredibly heavy and it starts to sag and it's no longer a perfect cylinder, you have a non-cylindrical fold. This is the most basic non-cylindrical fold. Basically, it's been folded in 2 different directions. One was that original cylindrical fold, and then it started to sag in the middle, and therefore there's a new fold right in the middle. Oops, I don't have the picture right here. I'll show you later. Non-cylindrical folds can be far more complicated as well, but this is a nice basic non-cylindrical. A harmonic fold is a special kind of fold where the layers have roughly the same wavelength and amplitude for all the layers. This is kind of special because normally the ones in the middle, like layers 1 and 2, and even layer 3 in this example, will be more squished. They will have a smaller wavelength. But if the conditions are just right, and you have some decoupling, which we'll talk about later, but only mildly decoupled, you can end up with a harmonic fold, and the layers all have basically the same wavelength. Not perfect, but really close. This happens to also be plunging, which we'll talk about shortly. Disharmonic folds, on the other hand, have different amplitudes and wavelengths within a fold system. So you can see here we have some that are really kinked up and small little folds, and some that are bigger with longer wavelengths, and they're very irregular and uneven. At the top, very disharmonic. At the bottom of this image, starting to approach harmonic, where these folds at the bottom here are reasonably similar to each other, but not quite as pretty as in the drawing, which isn't a surprise that real life isn't as precise as the drawings. But so this is disharmonic, especially up at the top. Now, detachment. This happens when layers kind of detach or decouple from each other, and so they can fold differently. Sometimes one layer or a set of layers will fold and the others won't fold whatsoever. Like right here, we see this area here where I'm pointing with the mouse, very straight. Oops. Directly under it, very folded. So for that to happen, there had to be decoupling. Basically, as these layers folded, they slid along the bottom of this one. It's kind of like if you have, say you set a textbook on top of a pile of towels, and then you use your hands to push on the towels and squish them up. The towels will fold, just like this rock here has folded, The textbook will not fold. The towels will just slide. They're not adhered to the textbook. There's decoupled. The rock decouples. It can slide and fold differently than the rock next to it. The towels are decoupled. They can slide differently than the textbook. So that's a detachment fold. Now, going to have an in-class assignment of sorts where you are going to take a piece of paper. Go ahead and do this right now. I'll give you, some time. Plus, of course, you can pause the recording. In class, I wait until everybody's done drawing. But take out a piece of paper. It could be notebook paper or printer paper or whatever, and draw a fold. I'm talking, a geology fold. You can do anything. Use your imagination. You've seen a bunch of folds already so far today. You've seen some that are all kinky, some that are very regular, some with 2 layers, some with like 15 layers. You've seen them in 2D, you've seen them in 3D. So I want you to draw something. So any kind of fold you feel like. Make sure it has to have at least 2 rock layers. 2 to 5, I wouldn't go more than that, just because it's going to take you a lot of extra time. And then specify which is the oldest and which is the youngest. The assumption is that, one edge or surface is the oldest, the opposite is the youngest, and in between they go in consecutive order. It would have to be very special conditions to change that, but let's go with that right now. So maybe oldest is on the bottom, maybe oldest is on the top, maybe oldest is on the left or the right, depending how you draw your fold. Just make sure you pick and you identify it with like an O and a Y for oldest and youngest. Now, once you're done your drawing, and if you need some more time, even beyond my explanation period here, go ahead and pause the recording so you can finish your drawing. Then you can resume your thing, resume watching the lecture, but keep that paper because you're going to do some more with it and then turn it in after the lecture's over. But it is somewhat important, it's going to work better if you finish your drawing first before you go on with the lecture. Otherwise, it'd be too easy to decide, oh, I'm going to draw this and I'm going to draw that because of what I heard. The idea is to draw the fold, then we'll figure out what it is. So once you've finished your drawing, come on back and unpause this, and we can continue. Now, antiform and synform. Not the terms that you probably heard in like a Geology 101 or Earth Dynamics type class of anticline and syncline, but they sound awfully similar. And it's because they are very similar. Antiform means the hinge is at the top. You may look at this picture on the left and say, oh, why call it an antiform? That's an anticline. I'll explain the difference in just a moment. Synform, hinge is at the bottom. Now, the big important thing here is that you have no idea which layer is oldest and youngest in these pictures. Nothing is labeled. There are no fossils. There's no radiometric dating. There's nothing except drawing of layers. So you don't know. That's why it's an antiform and a synform, because you don't know. But you know the shape, you know the orientation of the folding, and so you can still talk about it.